What is up, everybody? Welcome to Chapter 4. We have spent 3 chapters basically dealing with straight lines, and now we're going to start dealing with curves. So buckle up, here we go. Section 4.1a, graph quadratic functions. Everybody take a moment right now to just say the word quadratic. Yeah, quadratic it's going to mean, the very short version is that we're going to see lots of these exponents, x squared. Quadratic functions in standard form with a vertical translation. Okay, so just a quick review for PEMDAS. If you see something like this, then you want to make sure you do exponents for, well, if there's any parentheses, which right now there aren't, but maybe next section there will be. You do parentheses, what's inside parentheses first, and then you do exponents. There is a set of parentheses right here, but there's no operations inside to prioritize. So exponents, in this case, wins out first. So negative 2 squared is 4. Remember, negative times a negative is a positive. And then multiplication you do next, which is 16, and then you do the subtraction last to get negative 14. We're going to see stuff like that today. Okay, new kind of table. Because we have x squared, we're going to have to do more than just 2 or 3 different rows, as you've seen before with straight lines. But because of this quadratic function, we have to actually do 5. There's a shortcut, and I'll show you what it looks like soon. Okay, so here's what it looks like. You see, there's some symmetry going on. There's a middle right here, which is, in this case, 0. And that's kind of the default. And I'll show you why later in a second. But all the questions in this section are going to have 0 in the middle. And they're going to have 1 and 2 on this side, and then negative 1 and negative 2 on this side. 0 times itself is 0. 1 times itself is 1. 2 squared is 4. Negative 1 squared, remember, negative times negative is a positive. It becomes also positive 1, just like this one down here, positive 1. Negative 2 times itself is 4. So you're going to have 4s on either side as well. There's a certain symmetry that goes on. And as you can see, even here, that symmetry gets played out in the shape of a curve. We're graphing these 5 points here, 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 and here, and here. And they curve around like this in what's called a parabola. New vocabulary word, everyone say it, parabola. Yeah, fun. Okay, you noticed when I said there was some symmetry, there's like this 1 and 1, and the 4 and the 4. Turns out the parabola is symmetric, and we can put a dotted line along the y-axis. It's not part of the graph, it just shows you where the axis of symmetry is. Let's do the same thing again. Very similar, x squared plus 2. This time, we're not just going to square the numbers, the x values, we're going to square them and then also add 2. This is what it looks like. 0 squared is still 0, plus 2, we got 2. 1 squared is still 1, but then you add 2, you get plus 3. 2 squared is 4, plus 2 is 6. And the same numbers appear on the other side as well. So what you're going to get is you're going to get something very similar, except it's just been shifted up 2 units. It's been vertically translated. Everyone say vertical translation. I didn't hear you. There it is, a lot better, thanks. Okay, so, and this dotted line is going to be put in place just to compare it to what you might be calling the original. All these functions over here are going to be like variations on a theme. They're going to be very similar to the x squared. But the difference is going to be that you can see this is just going to be all the y values got added to 2. They're all 2 units higher than the parent function than the original. So that's why we've got a dotted line to compare, and then the actual graph is here, red. And it's still the same axis of symmetry going down the middle. 3 times x squared. Okay, so we've got all these same numbers being squared. It's still 0, 1, 4, 0, 1, 4. And now you're going to multiply them all by 3. So these are all these numbers here, except they've been multiplied by 3. And as you might see here, it's just been stretched. It's still 0, 0, but quickly, it doesn't exactly have the same thing as a slope, but if it did, you could see that the slope is drastically much higher than before. lastly, our last example this is the last of the 4 examples for today. You can see it's 2 minus 4x squared. So it's going to be a little bit more difficult to calculate, but we just basically say 0 squared is 0, then times 4, and then 2 minus 0 is still 2. Sometimes you might need more than one line to show all the work you need, but right now I'm gonna do just this in one line. PEMDAS says you do the exponent first. 1 squared is 1 times 4 is 4, and then 2 minus 4 is negative 2. 2 squared is 4. 4 times 4 is 16, and then 2 minus 16 is negative 14, just like we said over here. And then the symmetry is going to say that the same thing is true over here. So when you plot the points, it looks like this. Really different from the original. How is it different? Well, you can see, first of all, it's the original was in the shape of kind of a U, and this is in the shape of an N. So it's been flipped upside down, so to speak. And then you can see these two, it's also the very center point is at 0, 2, just like it was over here. So there was simultaneously there's like a vertical translation of 2 units up, and then there's also a vertical dilation or a flip. All right, so let's start describing these graphs. Domain. What is the collection of all the x values? If you wanted to think about all the x values in this graph, it doesn't stop there, even though we've only graphed a few points. Just like lines, these parabolas will go on forever. They go on forever vertically and also horizontally. And in fact, there's no number you can't put in for x that you can't also square it and find out what the y value is. So the domain is going to be all the x values from negative infinity up to positive infinity. That's the collection of all the x values among all the points. And if you were to make the table as long as possible this way and that way, expanding the table forever, that's what you would see. The domain is all the x values from negative infinity to positive infinity. This is not a point anymore. I know there's lots of parentheses, but it's not. This is interval notation. It's a collection of all the numbers from negative infinity to positive infinity. What's the maximum maximum y value? Well, in most of these instances, it goes up as high as you want, so it goes to positive infinity here and here and here. However, the maximum y value here is 2. You can see it goes down as far as you want because the whole thing got flipped. So the highest y value you could possibly expect is 2, and it occurs right here when x is equal to 0. All the other y values are less than 2. You can see it here, and you can see it here. So the maximum y value is here. What about the minimum y value? Minimum y value, in this case, is 0. It goes down. The lowest y value here is 0, and the lowest y value here is 0. Here, the lowest y value is 2. You can see it on the table as well. That's because the whole thing, it used to be 0, but then it got shifted. The whole parabola got shifted up 2 units. Here, the minimum y value is 0. And here, the minimum y value, again, this should be a negative infinity. There we go, negative infinity. Okay. What's the range? So the range, therefore, is very much like the domain. It's going to be the collection of all the y values, and you write them from the lowest, the minimum y value, up to the maximum y value. So here, we're going to take the last two answers and combine them. The range is from 0 to infinity. And notice we are using interval notation requires that we talk about this with square brackets. So it goes from 0 is actually included as when we collect all the y values, 0 is actually included as a y value. So we're going to put a square bracket here. And then infinity isn't really included because infinity isn't a number. You can't ever reach infinity. We're going from 0, starting and then including 0, all the way up to positive infinity. Same thing here, except for starting at 2. The minimum y value is 2, and it goes up to positive infinity. Here, 0 is the same thing. And here you can see the interval gets written as parentheses negative infinity, because remember it's the lowest infinity, and it goes up to positive 2 with a square bracket. So I'll let you figure out what's underneath the red dot. I think I just said the answer. Speaking of saying the answer, I just wanted to drop in there right now that my favorite hobby is rock climbing. I got tons of photos of me climbing on rocks on my camera roll if you ever want to ask. But maybe you could tell me what your favorite hobby is when you come into class tomorrow. All right, next. Vertex. Where is the vertex? What is the vertex? The vertex is going to be this point right here at 0, 0. It'll get moved around and shifted, but it's basically the point that's also along the axis of symmetry. The very bottom right here, or the very top right here. That's the vertex. So if you wanted to actually, okay, so it's going to look confusing because this parenthesis means different from this set of parentheses. This is actually a location on the graph. It's a set of coordinates. It's 0, 0. It's not interval notation. This is interval notation, this is interval notation, and this is a set of coordinates. And they all use parentheses, which is super confusing. Oh, and this is also using a set of parentheses, and that's PEMDAS to group operations. So you're looking right here in the same lesson, you're looking at 3 different ways to use parentheses. By grouping a grouping symbol, interval notation, and set of coordinates. This is when we say the vertex is at 0, 0, we're referring to a location on the graph, which is right here, 0, 0. Here the location on the graph of the vertex got moved up 2 units, but it's still right there. You can see here the vertex is at 0, 0, and here the vertex is at 0, 2 because it got moved up a little bit, and then it got flipped. Flipping it doesn't actually change where the vertex is. Transformation. So here we're going to start talking a lot about transformations. And what is a transformation? Well, to understand what a transformation is, you have to understand what a parent function is. So this is, you might call this the parent function, and then these functions are based on the parent function, but they've been transformed somehow, transformation. So there's no transformation here, it's the parent function. But compared to the parent function, this one has a vertical translation of 2. It's been translated vertically 2 units, as you can see right here. This one has a vertical dilation of 3. Sometimes people say vertical stretch of 3. But depending on the textbook and the format, they might use some slightly different vocabulary. In any case, it's because there's some multiplication here, times 3. All the y values got stretched 3 units vertically. And here you've got both. You have both the vertical translation of 2 from the plus 2, and then there's a vertical dilation of negative 4. You can see that from the minus 4 times x squared. So the multiplication is what gives you the dilation, and the addition and subtraction is what gives you the translation. So this one also got vertically translated up 2. That's why the vertex is 2 units higher. And then it also got stretched. You can see it's skinnier than the original. And then it also got flipped, so that dilation is negative. Okay, axis of symmetry. We've been talking about this a while. What exactly is the equation for this line? Here, you can say it's x equals 0. It's the vertical line, x equals 0. Here, it's also the vertical line, x equals 0. All 4 of these, the axis of symmetry still is always the line x equals 0. All right, last part. Write the equation of a parabola with a vertex. What if we started with this information down here and then had to somehow work backwards to get the answer, which would be one of these up here or something like it up here? Well, let's start by, if we know the vertex 0, 3, if it's a parabola, it's probably going to be of this format somehow, like some number, not 3, but like we'll call it ax squared plus some other number over here, k. So let's start by writing that down and then filling in the blanks of what we know. Y equals some number, I don't know what it is, x squared plus k. And the whole goal is to try and find out what a and k are going to be. In fact, you can see, we'll just fast forward to the end. A happens to be negative 8 and k happens to be 3. Let's talk about how we know. All right, the vertex, we know if the vertex is at 0, 3, that means it had a vertical translation of 3. Like This one had a vertical translation of 2. This one needs a vertical translation of 3. So that means the k value here is going to be 3. And then if we wanted to say that the point was 1 comma negative 5, if it had to go through the point 1 comma negative 5, we could actually put this for x and this for y temporarily, and then solve for a. You can see the y value goes here at y equals negative 5, and the x value is 1. So it's negative 5 where the y is, equals a is really what I'm trying to find. X squared instead of x, it's a 1, and then 3 here. If we're going to solve all this, you could say that this 1 squared is 1, and then subtract the 3 from both sides. You get a is equal to negative 8. And so if a is equal to negative 8, then we're done. We know what the answer is. The answer is this equation, y or f of x. You could say like f of x if you wanted to, but I'm just going to use y. Y is equal to negative 8 x squared plus 3. Yay! All right. Thanks, y'all. Bring your questions to class, and I will see you in class. Take care.